Consider rolling a loaded six-sided die 500 times. The die is weighted so that the number 5 comes up half of the time, while the other numbers come up equally often amongst themselves. So, ignoring the 5, what we're saying is the probability of rolling a 1 is the same as rolling a 4, is rolling a 6, is rolling a 2, is rolling a 3. So they're all equal, except for the 5, it's weighted so that 5 comes up 50% of the time. Okay, determine a random variable which counts the number of odd numbers rolled. Okay, now when we take a look at what's going on in this experiment, something is being done repeatedly. And we're interested in counting a specific outcome, how many times a specific outcome occurs, and that is the language of a binomial random variable. BNP counts the number of times when an experiment is repeated n times. It counts the number of times that a particular outcome or set of outcomes that have a probability together of p occur. Right, so it counts that. So we just now need to decipher, okay, we know it's a binomial random variable. What should the n be? What should the p be? Well, we can see the experiment's being repeated 500 times. So our answer here is going to look like b 500, and then what's p? Well, what are we interested in? We're interested in odd numbers being rolled. So we need to figure out what's the probability that an odd number is rolled. Well, 1, 2, 3, 4, 5, and 6 are the possible outcomes of a six-sided die. Now we know the probability of 5 happening is 0.5. And that leaves 0.5 for the others, and that's being split equally amongst the other 5 outcomes. So each outcome occurs with a probability of 0.1, 1/10 of the time, we might say. Okay. Now we just want odd numbers, so 1, 3, and 5. So the probability of a 1 is 0.1. The probability of a 3 is 0.1. The probability of a 5 is 0.5. So the probability of an odd number being rolled is the sum of these, because it could be a 1 or a 3 or a 5. So that's 0.7, or we could say 7/10, and that's the probability that we're interested in. So we could write it this way, or we could say 7/10. But either one of these binomial random variables will count what we're interested in.